In this video, we will learn about some common forces in mechanics. In mechanics, we encounter several kinds of forces. The gravitational force is the common one we know. Every object on the earth experiences the force of gravity due to the earth. Gravity also got the motion of celestial bodies. The gravitational force can act at a distance without the need of any intervening medium. All the other forces in common in mechanics are contact forces. As the name suggests, the contact force on an object arises due to the contact of the object with some other solid or fluid object in contact. When the bodies are in contact, like a book resting on a table, a system of rigid bodies connected to the cones, hinges and other types of support, there are mutual contact forces for each pair of body satisfying the third law. The component of contact forces normal to the surfaces is contact called as normal reaction force. The component parallel to the surfaces in contact is called as friction. Contact forces arise also when solids are in contact with fluids. For example, a solid immersed in the fluid, there is an upward buoyant force equal to the weight of the fluid displaced. The viscous force and the air resistance and other are some examples of the contact forces. Two other contact forces are tension in a string and the force due to the spring. When a spring is compressed or extended by an external force, a restoring force is generated. This force is usually proportional to the elongation or compression with the small displacements. The spring force F is written as F is equal to minus kx, where x is the displacement, k is the force constant. The minus sign denotes that the force is in the opposite to the displacement from the unstretched state. For an unextensible string, the force constant is very high. The restoring force in a string is called tension. It is customary to use the constant tension T throughout the spring. This assumption is true where the string is negligible mass. At the microscopic level, all bodies made up of charged constituents, which include nuclei, electron and protons, and various constant forces arising due to the elasticity of the bodies. Molecular collisions and impact, which will ultimately be traced between the charged constituents at different bodies. The detailed microscope origin of these bodies, however, complex and not useful for handling the problems in the mechanics at the microscopic level. This is why they are treated as different types of forces with their characteristic properties, which is determined empirically. In mechanics, we encounter several kinds of forces. The main contact force in mechanics is friction. Friction is defined as an opposing force which is set up between the two surfaces in contact when one body slides or rolls or tends to do so on the surface of another body. It acts on both the bodies tangentially on the surfaces in contact and obey the Newton's third law. First one, limiting friction. The force of friction between two bodies in contact when one body is in a position to just begin to slide over the surface of another body. Static friction. The force of friction between the two surfaces in contact before one body actually starts moving on the surface of another body. Kinetic friction. The force of friction between the two surfaces in contact when one body is in motion on the surface of another body. Rolling friction. It is defined as the friction that comes into play when the bodies like a ring, disc, sphere or cylinder rolls or tends to roll over the surface of another body, like as you're seeing in the car example over here. Rolling friction is less than the sliding friction always. Friction is useful in so many places. Friction is always opposes the motion and energy is dissipated in overcoming the friction. But at the same time, it is necessary because it helps us in walking, moving bodies, and transmitting power. So let us look into the friction with the help of the equations where we can compare the different type of frictions. So the first one, static friction. We have a object which is going to be placed on this table where the object will be having a force of gravity acting on that, which will be giving the weight of that equal to mg, and it will be having a opposite force in the upward direction, which is termed as normal reaction force N in the opposite direction. Both of them should be equal. Suppose if the body is being supplied with a very less amount of force, in practical it won't move, so there is no friction as well. Suppose if the body is being supplied with the force F, where the only external force on the body, and the body must have moved with an acceleration of A, which will be given by A is equal to F over m. However, this will be small. Then there is a friction is also acting on it as it's going to move. Clearly, the body remains at rest because some other force comes into play in the opposite direction to the applied force, resulting in the zero net force on the body. The force F, that is small f, parallel to the surface of the body in contact with the table is known as frictional force, or simply friction. Here the subscript S denotes the static friction and K denotes the kinetic friction. Static friction does not exist by itself. It comes into play the moment there is an applied force F increases, as in the previous case. Fs also increases as the supplied force increases, remains equal and opposite to the applied force. That is also up to a certain limit. After that it will move. Since the body is at rest, the friction is called as the static friction, and it's denoted by the symbol or the letter Fs. Always the static friction will be more. So it will be always opposing the movement of the object, or it will stop the object from moving. Here the impending motion means the motion that would take place under the applied force. Until that, there won't be any static friction. So when we supply the force of F which exceeds the magnitude of the static friction Fs, then the object begins to move. It will have few rules associated with that. They'll come under this law of limiting friction. So the first one, the Fs max, that is the static friction to the maximum, is independent of the area of contact, and it varies with the normal reaction force approximately, which is going to lead as Fs is directly proportional to the normal reaction force, and normal reaction force will be given by, that is the same thing, we are writing a constant mu s, which is the coefficient of friction. You could able to see, so that can also be called as the proportionality constant over here. So the coefficient of friction or static friction or the proportionality constant in the static friction will be given by Fs max, that is force of friction over normal reaction force. So the law of static friction may also be written as the static friction will be less than or equal to the magnitude of coefficient of static friction into normal reaction force. When it comes for the case of sliding or kinetic friction, then that will be represented with the letter Fk, kinetic friction. The object is going to be in movement. That means if the applied force F exceeds the limit of the static friction, then the body begins to slide. When the relative motion has started, the frictional force decreases from the limiting static friction. So obviously if the object is going to get into motion, the friction over there now is called as the kinetic or the sliding friction, which will be denoted by Fk. When it's going to come for the law over here, once again it is also not going to depend upon the area of contact, and nearly it is independent of the velocity of the object as well. When it's going to come for it, obviously it is going to vary with the normal reaction force which is acting on that. Once again we'll have the same one, then the constant of proportionality we'll be having, which is nothing but the coefficient of static friction, sorry, kinetic friction, what we are going to have. And the law of the kinetic friction can also be written as follows. The object is getting into motion, right? So there is a net force acting on that. That can be found by finding the net difference in the force applied and the kinetic friction over the mass. For a body moving with constant velocity, the force will be equal to the kinetic friction what you are going to have. If the applied force on a body is removed, then the acceleration will be given by minus Fk over m. that is eventually the body comes to rest. The law of friction do not have the status of fundamental laws like those of gravitational, electric as well as magnetic, but they are having the empirical relations. The rolling friction is going to be the friction between the surface when it's going to be in rolling. At every instant there is just one point of contact between the body and the plane, and this point has no motion relative to the plane. So you would able to see it over here as the ball rolls or the wheel which is going to roll over here. So that means that in the ideal situation, kinetic or static friction is 0 and the body should continue to roll with constant velocity. However, in practice this is not happen and the body comes to rest eventually. To keep the body rolling, we have to supply the force which is needed for it. This says that the rolling friction is much smaller, that is in terms of 2 to 3 orders in magnitude less than the static and the sliding friction. Rolling friction has a complex origin, which means that it could able to deform the object momentarily, and because of that there will be an impact on the net area what has been covered as well. So the net effect is that the component of the contact force parallel to the surface opposes the motion. Friction is a necessary evil. In many situations, friction has a negative role. It opposes the relative motion and hence dissipates more power in the form of heat, like in a machine with different moving parts. It causes wear and tear of machinery parts in contact and the tire of automobiles. In many practical situations, however, friction is critically needed. First one, brakes in machines and automobiles use friction to stop the motion of them. We cannot walk without sufficient friction. It is impossible for a car to move on a slippery road. On an ordinary road, the friction between the tire and the road provides the necessary external force to accelerate the car. We can reduce the friction as well. So the methods of reducing the friction. First one goes like this. The solids like graphite or the semi-solid like the grease and the liquid like the oil, that is we used to call them as lubricants, can be used to reduce the friction. Sometimes we use ball bearings to reduce the friction when it's going to roll on each other. A thin air cushion can be used between the solid surfaces to reduce the friction also. A proper combination of alloy surfaces can reduce the friction, because different type of metals won't get tear or wear out when they're going to move on each other. Like you see over here, the ball bearing case, how it works. As the wheel turns out, the ball bearings are also in motion, so that the tough contact, that is we will be avoiding the static friction. And you could able to see the air jet, that is the air which is going to be filled over there. Yeah.